G'day viewers. In this episode we are going to decompose and critique the Tshipa research article titled Obtaining Subatomic Particle Sizes from Creation-Annihilation Processes, which was published in the International Journal of Physics and Applications on the 9th of January 2020. Tshipa's formalism produces impressive results and is definitely worthy of consideration. In order to execute our decomposition and critique of Tshipa's research article, we utilise his solution framework as a roadmap. From this, we reinterpreted his derivational process flow via the electrogravimagnetic construct and produced identical numerical results. In doing so, we mathematically proved that certain propositions asserted by Tshipa are invalid. On balance, Tshipa's derivation denotes excellent scientific research. However, it is worth recognising that when identical results are achieved via an alternative solution pathway, then reconsideration of the original formalism should be executed. In no way does the solution pathway we present detract in any manner from the originality of Tshipa's research. We insist that full credit for the solution we present rests with his original formalism. The most important conclusions we formulated were that Tshipa's results may be reproduced. Number 1, without consideration of any electromagnetic properties. Number 2, without consideration of spin angular momentum or helicity. Number 3, without consideration of mass moment of inertia. Thus, we conclusively demonstrate that Tshipa's results, number 1, depend solely upon particle mass. Number 2, all the baryons, mesons and bosons presented may be modelled as point particles. Okay, that's enough chitty-chat from me. Let's get into it. Let's begin our journey by identifying where the Tshipa research article can be found. You can see that it has been published in the International Journal of Physics and Applications on the 19th of January 2020, as well as being published on ResearchGate in April 2020. The title of the research article is Obtaining Subatomic Particle Sizes from Creation-Annihilation Processes. Equally important is our decomposition and critique of the Tshipa research article titled Analysis of the Particle-AntiParticle Pair Representation of Fundamental Particle Sizes Solution Algorithm, which was executed in July 2020. Okay, now that you know where to find the primary artifacts, let's investigate and interpret Tshipa's theoretical construct. In section 2 of Tshipa's research article, he explains the theoretical formulation of his construct. However, in truth, I found it a little difficult to follow in the absence of an illustration. A diagrammatic representation would have gone a long way in communicating the desired concepts effectively. Nevertheless, we have pressed ahead based upon our best interpretation and efforts. Tshipa speaks of photons being gravitationally bound into a photon ring. What Tshipa means by gravitationally bound, or the associated mechanism enabling it, is unclear. To overcome this impasse, we have interpreted gravitationally bound to mean functionally bound. That is, the binding mechanism is irrelevant. Only the fact that two photons are somehow bound together is relevant. Moreover, we step back from the concept of two photons being functionally bound in favour of a more generalised condition, that is, two populations of photons being functionally bound together. Tshipa states that the energy density of the so-called gravitationally bound photons warps the geometry of spacetime, which manifests as mass in the form of particle and antiparticle pairs. On this premise, if the two photons are to produce a particle and its antiparticle, then their energies must be sufficient to produce the particles with their masses. What Tshipa is describing in his research article seems to be remarkably similar to the conjugate photon pair concept embedded into the electrogravimagnetic construct developed by Storti and in 2005. On the presumption of this similarity, we shall interpret Tshipa's formulation in the context of the electrogravimagnetic construct, that is, through an electrogravimagnetic lens. Hence, appearing on screen is our interpretation of Tshipa's theoretical formulation. Some viewers may recognise this illustration from previous electrogravimagnetic videos and research articles. The particle-antiparticle pair representation depicts two functionally bound conjugate photon populations such that the photon 1 population represents a particle, whilst the photon 2 population represents its antiparticle. As per Tshipa's requirements, these functionally bound photon populations loop into a rotating energy ring as appears on screen. Please also note the associated assumptions and/or constraints specified. The tangential velocity of rotation is constrained to the speed of light c, and the translational velocity of the rotating energy ring is 0. Of particular importance are the integer properties associated with the rotating energy ring. In his research article, Tshipa declared that the photon ring is imbued with angular momentum, thereby possibly accounting for intrinsic particle spin and helicity. This is an extremely important assertion made by Tshipa, which we shall disprove in the coming slides. In fact, we shall demonstrate that Tshipa's solution for particle radii is completely independent of spin angular momentum, and all of the particles listed by Tshipa may be modelled as point particles with zero mass moment of inertia. Thus, if the mass moment of inertia can be shown to be irrelevant, then spin angular momentum is also irrelevant with respect to particle radii. Lastly, before we move on to the particle radii derivation process, we shall run through our governing equations. As appears on screen, the essential artifacts are mass moment of inertia, rotational kinetic energy, linear kinetic energy, mass energy equivalence, and photon propagation energy. At this juncture, we recommend all viewers to pause the video and study the content appearing on screen. Once you feel comfortable, you can move on to the particle radii derivation process. The particle radii derivation process is remarkably simple. In fact, it can be reduced down to 3 basic steps in its succinct version, which we will demonstrate on the next slide. However, for the moment, we will walk through the process in a stepwise manner. Step 1. Formulate an expression for the total energy of the rotating energy ring as depicted on the previous slide. Step 2. Assume that the total energy of particles equals the propagation energy of photons. Step 3. Assume that the tangential velocity of each rotating energy ring is limited to the speed of light. Step 4. Assume that the physical measurements of each rotating energy ring occur in a co-moving linear frame of reference. Step 5. Assume that the circumference of each rotating energy ring is an integer multiple of photonic wavelengths. Step 6. For solutions satisfying unity, as appears on screen, the radii for all baryons is given by the equation shown. Step 7. For solutions obeying the process flow appearing on screen, the radii for all mesons and bosons is given by the equation shown. Step 8. Determine the minimum value of beta for mesons and bosons. Let me pause for a moment to emphasize that the following 3 steps are the most important. Step 9. Determine the mass moment of inertia value utilized by the Tshipa particle radii formulation. Step 10. Document the succinct version of the baryon radii derivation process. Step 11. Document the succinct version of the meson-boson radii derivation process. Okay, utilizing our stepwise particle radii derivation process and the associated lessons learned, let's take a look at Tshipa's published results. Tshipa's results contain 3 columns of quantitative information, that is, his calculated radii, the radii from a literature review, and the percentage deviation between them. As you can see, we have boxed the column containing the radii values from Tshipa's literature review. Why have we done this? Well, we have done this because no direct connection exists between Tshipa's calculated radii values and the electromagnetically associated radii values obtained from his literature review. Although Tshipa's results appear impressive upon first exposure, closer scrutiny reveals that there is nothing in Tshipa's particle radii derivation process which associates the form of radii appearing in the nomenclature with his calculated radii. In other words, as presented, Tshipa's calculated particle radii appear to be incomplete or unfinished, as they do not infer any like-for-like association with the literature review results. Tshipa does not reconcile the physical meaning of his radii results against charge radii, magnetic radii, electric radii, or simply radii. In the bottom right-hand corner of the screen, the Storti particle radii equations are presented, which do not contain any electric or magnetic terms. The fact that these equations do not contain such terms is extremely important, as you will soon see, so please keep this in mind. Let's now do a side-by-side comparison of the Tshipa versus Storti results. Storti's particle radii results present 4 significant features against Tshipa's formulation, as follows. Number 1. Storti's results match Tshipa's results precisely. By inspection, we can see that any differences between them are trivial and may be discarded. Number 2. Storti's particle radii equations do not contain any electric or magnetic terms, as discussed on the previous slide. Number 3. Storti's particle radii equations do not contain a spin angular momentum term. This is extremely important because it invalidates Tshipa's propositions regarding particle spin and helicity. Number 4. Storti's particle radii equations do not contain a mass moment of inertia term. This means that all the baryons, mesons and bosons presented may be modelled as point particles, where the mass moment of inertia configuration coefficient I sub x equals 0. As appears on the right hand side of Table 2, we have averaged the radii values stated in Tshipa's research article. Please refer to the previous slide. Moreover, we have concatenated the particle radii description obtained from Tshipa's literature review. By executing these changes, we are able to succinctly emphasise the lack of like-for-like association between Tshipa's calculated particle radii and his literature review results. Okay, let's now summarise what we have learned. On our journey, we have learned 6 significant lessons. Number 1. Tshipa does not provide a definition of particle size. This is an important formalism which should have been addressed. Number 2. Tshipa does not reconcile the physical meaning of his radii results against charge radii, magnetic radii, electric radii, or simply radii. Number 3. Tshipa's calculated particle radii appear to be incomplete or unfinished, as they do not infer any like-for-like association with the literature review results. Number 4. Storti's particle radii equations do not contain any electric, magnetic, spin angular momentum or mass moment of inertia terms. Hence, the spin angular momentum and helicity propositions raised by Tshipa have been invalidated. Number 5. Storti's particle radii results mathematically prove that Tshipa's formulation depends solely upon particle mass. Number 6. Storti's particle radii results mathematically prove that all the baryons, mesons and bosons presented may be modelled as point particles, where the mass moment of inertia configuration coefficient I sub x equals 0.